right, we're live. And we're looking at chain rule and product/quotient rule. So, if you are one of those students who, despite your grade 10 teacher telling you how important this new thing called factoring is, and then in grade 11 you still weren't great at it, so you just kind of got by anytime you saw quadratic instead of factoring it, you just went running to the quadratic formula to solve it. If you're one of those people that never really kind of got your head around how to factor well, the train ride is over. You are now about to hit a wall. If you can't factor, you can't do this. That's all there is to it. So anyway, with the doom and gloom warning out of the way, remember that we're using the chain rule, right? The chain rule says treat this interior of the bracket like it's its own variable, and then do a derivative of the variable. So that's like, if this was the derivative of x cubed, the cube becomes my coefficient, and then the variable stays the same, but it loses 1 on its power. But then the part that makes it the chain of the chain rule is I put another link on the chain here, and that link is the derivative of what's inside the bracket, which is 4x, right? That's the way the chain rule works. What if we have to combine that chain rule with product and quotient law? That's where we're at now. Okay, I'm going to make one quick change to this. I'm going to call this capital F. We did this before, where capital F of x is equal to the product of two, I'll use lower cases for those. And we, of course, learned that the product law says that if I want the derivative of that, it's the derivative of the first one times the second one plus the derivative of the second one times the first one. So that's what I want to accomplish with that function there that I'm calling capital F of x. So, you know what, I'm just going to do it and then see if I can show you where the parts are. So f primed of x is the derivative of the first one times the second plus the derivative of the second one. Did I miss? Oh, yeah, I did. Thank you. I missed a 2. Thank you. Good eye. And hang on, I guess I'll just finish this off here.
Please stand and remove your hats for O Canada and the
Times
treaty
x plus 1,
acknowledgement.
3. Okay, we'll just pause for O Canada real quick. Okay, we're live again. Okay, so I think I took care of it there before O Canada stopped me. All right, so let me just kind of show you what parts are what here. This part right here is, of course, f primed of x, and this part is g of x. Okay. This part here is g primed of x, and this part is f of x. So that's the quotient, that's the product law with a chain rule in it. Okay, so now what? Now we simplify using factoring. So now we're going to factor this thing. So let me rewrite it without the kind of stuff in the way. So f primed of x is, let's see, 3 times x squared plus 1 all squared times 2x times 2 minus 3x to the power of 4 plus 4 times 2 minus 3x to the power of 3 times negative 3 times x squared plus 1 all cubed, right? Yeah, there it is. Okay, so that's it. All right, where are my common factors? Well, do you notice that I can factor out, and let's think of this logically. Make sure you understand that there are, in fact, 2 terms here. That's a term, and that's a term, right? Because they're being separated by this add right here. So in those two terms, do you see your common factors? Do you see the 6? See where I got a 6 from? 3 times 2. And there's a 2 in this 4, and then this 3. So I'm factoring out a 6. Both terms can give me a 6. Both terms can give me x squared plus 1 squared. Right? I can factor it out of this one, and I can factor it out of this one, but keep in mind that's going to leave me one more factor of x squared plus 1. Both can give me 2 minus 3x cubed, right? Only there'll be one more of those factors here, and this one will be gone. Okay, so now that I've done that, now that I've factored out the common factors, what's left behind? Well, in this one here, this factor is completely gone, but this x is still here, and one of these factors is still here. Oops, let's get rid of that. And in my second term, I factored out the 3, and I didn't quite factor all of this 4 out. There's still 2 of it left, right? And instead of saying that the middle part of my factor has a factor that's a negative, why don't I just move that negative out front? Okay. I factored out the entirety of this factor, it's gone, but I only factored 2 out of the 3 of these factors out. And now you can see that this simplifies quite nicely. I would never bother to multiply these out. There's just no point. The idea is that, this might end up, remember, what does this represent? It represents the slope of some crazy curve. And if I want to start plugging numbers into it, I don't really want to expand these and have x's to the power of 5 and 6 and 8. Right now, they're fairly easy to work with the way they are. So this part's just going to stay the same. There's no point in expanding these guys. But over here, I can make this quite a bit simpler, right? I can multiply this out. X times 2 is 2x. X times negative 3x is negative 3x squared. Minus 2x squared and minus 2. And that's going to lead me to what I'm going to leave it as for my final answer. I'm going to leave it as, actually, you know what? I'm lying. I'm going to do 2 more steps. I just realized. So this now, if I simplify that down, would be 2x minus 5x squared minus 2. And I did stop there the first time I did this. And then, I did steal this example from an old textbook. So I looked at the answer key in the textbook, and I realized, oh yeah, I guess there is one more step of simplification, because we want these factors to be as simple as possible. And what's simpler, doing 2 adds and 1 subtract, or 2 subtracts and 1 add? Well, to a mathematician, the fewer times I subtract, the easier my math is. So this was the actual final answer here. And see if you can see what they did to get to it. Do you get what they did? If you factor a negative 1 out of this bracket, because it's cubed, right? So you can factor a negative 1 out of it. And you factor a negative 1 out of this bracket, those 2 negatives cancel each other, and I'm left with far more pluses than I had minuses in the first place. So this is the way they left the answer. And there it is. So remember, the overwhelming rule here is we want to use our factoring skills to get the factors as simple as possible, right? If I expanded this by foiling it and expanded that by, multiplying it by 3x minus 2 squared and then timesing it by another 3x minus 2, I don't make my life any simpler. I end up with more terms than I'm looking at right now. Right? Say, for example, I wanted to know what the slope of this curve is when x is 1. Isn't it right here about as easy as I can make it to plug a 1 in and figure out what that slope is? So that's the idea. We want to get the factors as simple as we can, but we leave it in factored form. All right, so that was product rule. Let's do a quotient rule. Okay, so in this case here, y has a function on top, I'll call f of x, and a function on the bottom, I'll call g of x. And remember that the quotient rule is, and no, we don't give this to you, you have to remember it. It's like, oh man, I memorized it for the last test, then I forgot it. Like, sorry, but you gotta remember it. You have to know the quotient rule. So it's low times the derivative of high minus high times the derivative of the low one, or low d high, high d low, as I always remember it, all over the derivative, or sorry, the denominator squared. So there's our quotient law. Okay, this one I'm going to write smaller because, boy, this one takes up a lot of room. All right, so, y primed. Away we go. What is g of x? Well, g of x is just x squared plus 3x minus 1. Let me make that prettier. All cubed. So that took care of this. Times the derivative of the top. Okay, well, that's not a big deal. The derivative of the top is 2x. Okay, so we just took care of that. Minus. Now here's where I got to use my chain rule. It's the top. So I just took care of that. But now I got to use the chain rule for the derivative of the bottom. So the derivative of the bottom is 3 times x squared plus 3x minus 1 squared times the derivative of what's in the bracket, which is 2x plus 3. And all of that, so there, I just took care of that part. And now we'll take care of this part. All of that is over the denominator squared, right? When you square a cube, it's now a power of 6. All right. What would we like to factor out of this? You know what we'd like to factor out of this is right here. I have 3 of this term, or factor I should say, and 2 of this factor. So both of these terms can give me x squared plus 3x minus 1 squared, leaving behind one of these times 2x minus x squared plus 2 times 3 times 2x plus 3. All over that. Okay, so now that it looks like that, I can do this as a divide, right? I can say this cancels 2 of these and leaves behind 4 of them. Now let's just multiply out the rest of that numerator and collect like terms, and we're good to go. So that's going to be 2x cubed plus 6x squared minus 2x. Now careful distributing that negative. I think I'd probably FOIL these two binomials together first and then multiply them by -3. So that's going to be, let's see, x squared times 2x is 2x cubed, but it's times a -3, so it's -6x cubed. Then it's x squared times 3 times another 3, which is 9x squared, but it's minus 9x squared. Then it's 2 times 2x, which is 4x, but I'm timesing that by -3, so that's -12x. And then it's 2 times 3 is 6, but I'm timesing that by 3 and minusing it, so that's -18. The denominator is not going to change anymore. Unless by some weird coincidence I end up getting this exact factor in the numerator. But you know what? If that were to happen, that would have meant that it would have been simplifiable at the very beginning. And I probably would have noticed that before I even started doing my calculus. Okay, y primed is equal to. We can put all this together and say that's 2x cubed minus 6x cubed is negative 4x cubed. We have 6x squared minus 9x squared is minus 3x squared. We have negative 2x's minus 12x's is negative 10x's. No, it's not. It's negative 14x's. Sorry. There we go. And minus 18 doesn't have anything to combine with. And once again, I'd kind of like my life as simple as possible. I see all those negatives in the numerator, and I think, why don't I just factor out a negative from all those and just slap it in front of the fraction? So there we go. That's the way I would leave my final answer. And there we go. Okay, so there's the second example with quotient rule. Let's go back to product, or let's do another quotient rule, but this time the quotient itself is in a power. So okay, what's this going to look like? All right, let's see. Well, y primed is going to equal the derivative of this thing. Pretend this thing is one variable, so 6 times that variable, you don't change it, but the power's now got a 5 on it, times the derivative of what's in the bracket, and the derivative of what's in the bracket is a quotient rule. So I'll use a big square bracket for this. And quotient rule again is low d high minus high d low all over low squared. Okay, let's tidy up that bracket a little bit. So I'm going to leave this one alone for now. So let's see, that's going to be 2x minus 2x. Oh, the x's go away, isn't that nice? But I am going to have a 4 minus a negative 1. So that's going to be 4 plus 1, right? 4 plus 1 is 5. So I'm going to get 5 on the top. And x plus 2 squared on the bottom. Okay. One last step to simplify this a little bit. Why don't I multiply the 6 and the 5? And then the rest of the numerator is just 2x minus 1 to the 5. And the denominator, this is x plus 2 to the 5 times x plus 2 to the 2. So why don't I just make that x plus 2 to the 7. And there we go. That's about as simple as I can make that one, I think. Okay, judging from that last test that I handed back to you today, some of you, your least favorite thing in the whole wide world might be switching from rational exponents to radicals and back. I'm sorry to tell you that that's not going to go anywhere. You have to get used to that. So look at number 4. We have ourselves a radical. Now, the way that I tend to approach these, and I think the way most people do this stuff is, you can't do calculus on a radical. But notice the calculus is actually over right here. Right? Calculus is over in one step. Same with back in the last example, right? There. Calculus was done right there. Everything else, I'm just using my algebra skills and my factoring to simplify things to something easier to work with. So I tend, when I hit ones like number 4 here, to switch to rational exponent form, do my calculus, and then go right back to radicals right away. So let's do that. Okay, so this is product law, but both of the factors of my product have chain rule that needs to be applied. So let's see. So first of all, let me just rewrite that as x cubed minus 4x to the 1/2 times 2x cubed minus x cubed. Now somebody might notice, hey, I could actually factor an x out of here. But doing it now would make this the product of 3 factors, and that would make life harder. Right now, it's the product of 2 factors. It's perfectly set up for product law, but keep that in mind, that we might be able to do something with that later. All right, here we go. Y prime. So, derivative of the first thing. Times, of course, the inside. Times the second thing. Plus the derivative of the second thing. Times the first. And actually, again, at this point, my calculus is over. Right? That's it. The calculus part's done. But right away, I want to get rid of my fractional and negative exponents so that I can start looking at this thing like it's polynomial algebra that I can work with. So y prime is going to be, okay, so let's see. I am going to take this negative power and move it to the denominator. This 1/2 is already going to the denominator. And a power of a half is, of course, the radical square root. So I have 3x squared minus 4, 2x cubed minus x cubed, all over 2 times the square root of x cubed minus 4x. There we go. Do you get how I got to there? Meanwhile, over here, I won't multiply anything out here yet. Oh, this one's not rational just yet. Okay, what do I want to do with that? Well, this is going to be simpler if I can make it one thing. So this side has a denominator, this one doesn't. So I'm going to multiply this term, and again, to me this is all one big term, by my common denominator. But of course, I have to do that without changing it, so I have to do that as, you know, a 1. Right? Okay, let's see what happens when we do that. Y primed is now 3x squared minus 4 times 2x cubed minus x all cubed plus 3 times 2x cubed minus x all squared times 6x squared minus 1 times another 2. I might as well just, you know what, now that I think about it, instead of 2 times 3 again, why don't I just make my life simpler and make that a 6? There we go. And then what happens if you times a radical by itself? It just becomes itself, right? Square root of x times square root of x is x. All over 2 square root x cubed minus 4x. Now you might be looking at that thinking to yourself, holy cow, that doesn't really factor. But actually, I see a couple of things I can do here. Again, think of this as 2 different terms, and I'm looking for the greatest common factor that I can take out of those 2 terms. So how about I'll just show you what it is, and then you see if you can see it. I can take out an x cubed from here. Maybe, you know what, maybe I will do this in 2 steps. I'll take an x cubed out of this one. Leaving behind, so basically I'm factoring an x out of here, but it's being cubed, so it's actually an x cubed. So that's now 2x squared minus 1. Still cubed. And I can take an x out of this term as well, but of course it's being squared. So that's 6x squared. And this is now also 2x squared minus 1, but this one's squared. And notice I can take an x out of here as well. So I'll do that over here. Okay. Do you see that there's an x cubed here? And if I take x squared times x, there's an x cubed there too. So y primed is going to equal, I'm going to factor out x cubed. I can also factor out the square of this term. So 2x squared minus 1 all squared. And that leaves behind 3x squared minus 4 times one more of this term, 2x squared minus 1. I still have this 6 here. This x squared's been factored out. This factor here has already been factored out. So I have 6x squared minus 1. This x has already been factored out. And x squared minus 4 all over 2 times the square root of x cubed minus 4x. Okay, let's expand this middle, this thing here and collect any like terms. Looks like it's going to end up being x to the power of 4. This part here is, I think, pretty much done, unless something else comes along to change that. But all right, so we have 3x squared times 2x squared, which is 6x to the 4. We have 3x squared times negative 1 is minus 3x squared, minus 8x squared is minus 11x squared. And negative 4 times negative 4 is plus 4. Over here, I have 6x squared times x squared, which is 6x to the 4, but I'm timesing it by 6, so that's 36x to the 4. I have 6x squared times negative 4, which is negative 24x squared, minus another x squared is negative 25x squared, but I'm timesing it by 6. 6 25s is 150. This one kind of gets big. And then negative 1 times 4, negative 4 is 4, but times 6 is plus 24. All right, let's collect our like terms in that bracket now. I have 6x squared and 36x squared is 42. Oh, sorry, x to the 4, I mean. 42x to the 4. Negative 11 minus 150 is negative 161. And 4 plus 24 is 28. And for a second, I thought, there, I'm done. And then I thought, oh, wait a minute. 42 and 28 have a common factor of 7. Does 7 go into 161? And I actually did some scrap work. Let's see, how many 7s go into 16? 2, and 16 minus 14 leaves behind a 2, which is 21. Yep, 7 goes into those, all those. So my final answer is going to be, I'm going to take out a 7 from all that, and I'll have 7x cubed, 2x squared minus 1 all squared, and 6x to the 4 minus 23x squared plus 4 all over 2 root x cubed minus 4x. And I don't think I'm making it any simpler than that. Sometimes people will ask, oh, don't you want to rationalize the denominator? That would just add more terms that I'd have to work with. It wouldn't make life any simpler because I'd be stuck with a radical up here and then just, I'd still have x cubed minus 4x. If I could see that somehow rationalizing this would combine it with one of the other factors, then I'd do it. But looking ahead, I don't see that being of any help. In this type of algebra, we don't really mind if we have a radical in the denominator. So that's where I'd leave that one. Okay. All right, that's it. That's today's lesson. I'm going to shut down the video here.